Understanding embedded systems. Embedded systems are specialized computing systems that are designed to perform specific tasks within larger systems. Unlike general purpose computers, which can run a variety of applications, embedded systems are built to execute a particular function and are usually embedded within a larger device or system. These systems are commonly found in everyday devices, from household appliances to industrial machines, and even in vehicles and medical equipment. Components of an embedded system. An embedded system typically comprises three main components: hardware. This includes the microcontroller or microprocessor, memory, RAM, ROM, input output interfaces, sensors, and actuators. The hardware is designed to interact directly with the environment, gathering data and executing commands. Software. The software in an embedded system is typically a firmware that is stored in read-only memory, ROM. It consists of a program that controls the hardware to perform the specific task. The software can be a simple control loop or a complex real-time operating system, RTOS, depending on the complexity of the application. Real-time operating system, RTOS. In more complex systems, an RTOS manages the hardware resources and schedules tasks so that they meet real-time requirements. For instance, in a car's anti-lock braking system, the RTOS ensures that the brakes respond within milliseconds. Characteristics of embedded systems. Embedded systems have several key characteristics that distinguish them from general-purpose systems. Specific functionality. Embedded systems are designed to perform a specific task, like controlling a washing machine or managing the engine of a car. Real-time performance. Many embedded systems require real-time performance, meaning they must complete tasks within a certain time frame. For example, a heart monitor must process data and provide feedback almost instantly. Resource constraints. Embedded systems often have limited resources, such as memory and processing power, since they are designed for specific functions. This requires efficient software design to ensure optimal performance. Low power consumption. Since many embedded systems are used in portable or battery-operated devices, they are designed to consume minimal power. Reliability. Embedded systems are often used in critical applications where failure is not an option. As a result, they are designed for high reliability. Types of embedded systems. Embedded systems can be classified into several types based on their functionality and complexity. Standalone embedded systems. These operate independently without requiring a host system. Examples include microwave ovens, digital watches, and calculators. Networked embedded systems. These systems are connected to a network, allowing them to interact with other devices or systems. Examples include smart home devices like thermostats and security cameras. Real-time embedded systems. These systems are designed to perform tasks within a strict time limit, making them suitable for critical applications like medical devices, industrial automation, and automotive safety systems. Mobile embedded systems. These are used in portable devices such as smartphones, tablets, and handheld gaming consoles. They are optimized for low power consumption and mobility. Real-life use cases and examples. Embedded systems are integral to many devices and applications we encounter daily. Here are a few examples. Automotive systems. Modern cars rely heavily on embedded systems for various functions, such as engine control units, ECU, anti-lock braking systems, ABS, and airbag control. These systems ensure safety, efficiency, and performance. Medical devices. Embedded systems are used in medical equipment like pacemakers, insulin pumps, and MRI machines. These systems provide real-time monitoring and control, ensuring patient safety and effective treatment. Consumer electronics. Devices like smartphones, smart TVs, and home appliances all contain embedded systems that control their operation. For example, a washing machine's embedded system manages the water level, temperature, and spin cycle. Industrial automation. In factories, embedded systems are used in robotic arms, conveyor belts, and control systems to automate production processes. These systems improve efficiency, reduce errors, and enhance safety. IoT, Internet of Things. Embedded systems are the backbone of IoT devices, which are connected to the internet and can communicate with each other. Examples include smart thermostats, wearable fitness trackers, and connected refrigerators. Embedded systems in the future. The role of embedded systems is expanding as technology advances. With the growth of the IoT, autonomous vehicles, and smart cities, the demand for sophisticated embedded systems is increasing. These systems will continue to evolve, becoming more intelligent, efficient, and integrated into our daily lives. Conclusion: embedded systems are a crucial part of modern technology, enabling the operation of countless devices and systems across various industries. By understanding their components, characteristics, and applications, we can appreciate the importance of embedded systems in making our world more efficient, safe, and connected. As technology progresses, embedded systems will continue to play a vital role in shaping the future.